All right, let's jump right in, shall we? You've sent over a ton of these new AI research papers, a whole bunch of them fresh off the press from ERISIC. And they're all from today, January 20th, 2025.
It's really amazing the sheer volume of work being published right now. It feels like you're getting a real-time snapshot of what the AI world is buzzing about.
Yeah, definitely. And it's not just like, one narrow area. We've got papers on everything from like theoretical improvements to deep learning to like really cool practical applications.
Absolutely.
So we're going to see stuff about like fine-tuning algorithms, scaling up those massive models everyone's talking about, and even I think some papers grappling with those big questions about AI safety and ethics, which always sparks a good conversation.
Always a good conversation.
So the mission here is to, I guess, pull out those like golden nuggets of knowledge without getting too lost in the technical weeds, right?
Exactly. Let's highlight the most impactful and thought-provoking stuff without, drowning in jargon.
Perfect. And maybe even have some, aha moments along the way.
Yeah, I'm always up for an aha moment.
Cool. So why don't we kick things off with this group of papers that are all about making AI models, more trustworthy and efficient.
Sounds good to me.
Okay, cool. So there's one here that really caught my eye. It's called Spade and Gag. It's claiming to offer, get this, provable protection against both adversarial attacks and out-of-distribution data. Now, that's a pretty bold claim, right?
It is. It is. You don't see provable thrown around too often in AI research, so
Yeah.
that definitely piqued my interest.
Yeah, for sure. So I was digging into it, and it seems like they're using this thing called extreme value theory, which honestly sounds a bit intimidating.
Yeah, it's a branch of statistics that deals with, well, as the name suggests, extreme events or outliers. So not your typical everyday data points, but those rare occurrences that can really throw a wrench in the works.
I see. So are they basically looking at those outliers, those really unusual data points, to kind of anticipate where things could go wrong?
Exactly. It's like they're analyzing the extremes of the data distribution to identify potential vulnerabilities and then building safeguards directly into the model's architecture.
That's pretty clever. But like, what does that actually look like in practice? Like, how does that translate into making, say, a self-driving car safer?
Okay, so imagine a self-driving car navigating a busy street, right? Suddenly, something totally unexpected happens. A pedestrian runs out from between parked cars, or a construction barrier falls into the road. A traditional AI might struggle to react in time or make the right decision because it's never seen that situation before, but a model trained with this say-vite approach, it would be better equipped to handle these edge cases because it's already been exposed to and prepared for similar extreme scenarios during training.
So it's like you're giving the AI a heads up, saying, hey, weird stuff can happen out there. Be ready for it.
Precisely. And this could be a game changer for applications where safety is paramount, like healthcare.
Yeah, right. It's high stakes.
Yeah. Imagine an AI-powered diagnostic tool that's less likely to be thrown off by unusual symptoms or variations in patient data. That could lead to more accurate and reliable diagnoses, potentially saving lives.
That's a powerful idea for sure.
Mhm.
So Spade is all about preparing for those outliers, those unexpected events. But what about situations where the data itself is messy and mixed up? Like there's this other paper here on amortized Bayesian mixture models that seems to tackle that problem.
Yes. This one's for when your data comes from multiple sources, but you don't know which is which. It's a common problem in real-world applications.
But can you give me an example?
Sure. Think about spam filtering, the bane of our digital existence. You've got legitimate emails, marketing blasts, phishing attempts, all jumbled together in your inbox. And the challenge is that the underlying structure of each type of email can be quite different.
Right. They each have their own kind of like, fingerprint or something.
Exactly. And this model uses a clever combination of neural networks to figure out which email belongs to which category, even if the rules for each type are really complicated.
So it's like sorting through a pile of mail and automatically separating the personal letters from the bills and the junk mail.
Exactly. And what's really impressive is that this method works even if the underlying math for each source is very complex.
Got it. So it's all about bringing order to the chaos of mixed data, which, let's be honest, is most real-world data, right?
Absolutely. Real-world data is rarely neatly labeled and organized, so methods like this are essential.
Okay, so we've got Spade for handling outliers and this mixture model for dealing with mixed-up data. Now, I'm seeing a paper here on controllable momentum coefficients that seems to be all about speeding up AI training. And I know that training these complex models can take a lot of time and computational power, so any improvements there will be huge.
Oh, absolutely. Training time is a major bottleneck in AI research, and this paper builds upon a technique called Nesterov's accelerated gradient.
Okay, and what is that exactly?
It's a well-established method for speeding up AI training, but it has its limitations.
Like what?
Well, it's kind of like having a car with only one speed, fast, but not always the right speed for the situation. You might need more control, especially when navigating tricky terrain.
I see. So it's not just about raw speed, but about having more finesse, more control over the training process.
Exactly. And this new research introduces a way to precisely control the momentum of the optimization process, allowing for more efficient training depending on the specific data set and task.
So it's like being able to adjust the acceleration and braking of your car for a smoother and faster ride.
That's a great analogy. It's about finding the optimal path to the solution, not just blindly rushing towards it.
Okay, so that's controllable momentum, all about efficiency during training. And then there's this paper on conformal prediction for targeted coverage, which tackles AI reliability in a really interesting way.
This one is intriguing because it focuses on making sure AI predictions are reliable, but not in a uniform way.
What do you mean by that?
Well, instead of just trying to get a certain percentage of correct answers overall, it aims for accuracy when the AI is most confident.
Hold on. Isn't that when the AI is most likely to be right anyway? Why focus on those moments?
That's what's so clever about this approach. You see, those moments of high confidence are often when the AI is most prone to making big mistakes, leading to what we call critical failures. It's like double checking your work precisely when you think there's no chance you made an error, because that's often when those sneaky errors slip through.
Uh-huh. So you're saying it's about making the AI more self-aware, more cautious in those moments where it thinks it has everything figured out.
Exactly. By focusing on these high confidence predictions, the researchers are able to develop what they call trust scores, which provide a more nuanced measure of the AI's reliability.
Okay, that makes sense. So that's conformal prediction, a way to boost reliability where it matters most. All right, we've covered some pretty interesting advances in making AI models more reliable and efficient. What's next on our AI adventure?
Well, we can move on to the papers you sent over on image and video processing. There are some truly mind-bending developments happening in that area.
Okay, I'm ready to be mind bent. Let's hear about those.
Welcome back. It's incredible how much progress is being made in those fundamental areas, like making AI more reliable and efficient.
Yeah, it's
Yeah.
really impressive to see researchers tackling those core challenges head on. But now I'm excited to dive into those image and video processing papers you sent over. They seem to be pushing the boundaries of what's possible.
Absolutely. There's one here called SMP List X that's generating a lot of buzz. The researchers are calling it the ultimate body model for motion capture.
Ultimate body model, huh? That sounds ambitious. What makes this one so special?
Well, you know how traditional motion capture systems often struggle to capture the subtleties of human movement, especially when it comes to hands and facial
Yeah,
expressions?
like those really fine-grained details.
Yep. Exactly, but SMP List X goes beyond just basic body pose estimation. It captures those detailed hand movements, the subtle facial expressions, even the way clothing drapes on the body.
Wow, that's
Yeah.
impressive. How do they manage to capture all of that?
Well, it's all thanks to being trained on a massive data set of 40 different sources. They've really thrown everything but the kitchen sink at it.
So it's seen a lot of bodies in motion. But how does that translate into real-world applications?
Oh, the potential applications are huge. Think about creating more realistic and expressive animated characters for movies and video games. Or imagine virtual reality experiences that are truly immersive, where your avatar moves and interacts with the virtual environment just like you do in the real world.
That would be incredible. I can see how this could revolutionize fields like animation, gaming, and VR. But what about this paper on using lossy compression with stable diffusion? I usually associate stable diffusion with, AI art generation, not something as practical as data compression.
Yeah, it is surprising, isn't it? But it turns out that these powerful generative models can be incredibly effective at compressing images, especially when you need to achieve really low byte rates.
So they're basically using AI to, squeeze those image files down to a fraction of their original size without sacrificing too much quality.
Exactly. And this could be a game changer for applications like streaming high-quality video on mobile devices or transmitting large image files over limited bandwidth.
I see. So it's all about efficiency and making the most of those limited resources. But what are the trade-offs involved? I mean, eh, With any kind of lossy compression, you're always losing some information, right?
That's true. There's always a balance to strike between file size and image quality. But what's exciting about this approach is that it seems to outperform traditional compression algorithms, especially at those very low byte rates.
So better compression with less loss? That's impressive. It seems like we're constantly finding new and unexpected applications for these AI models. Now let's talk about the paper on Erase Bench, auditing concept erasure. This one seems to tackle a really important issue, bias in AI models.
This is an area of research that's gaining a lot of attention, and for good reason. We know that AI models can inherit biases from the data they're trained on, and these biases can have real-world consequences.
Absolutely. So how does Erase Bench work? Can it actually remove those unwanted biases from an AI's brain?
Well, a race bench is essentially a benchmark for evaluating different techniques for removing specific concepts from an AI model. Think of it like trying to surgically remove a tumor without damaging the surrounding tissue. It's a delicate process, and it turns out to be much more challenging than you might think.
So even if an AI model has learned some harmful stereotypes or biases, we can't just simply delete them.
Unfortunately, it's not that simple. The research shows that even state-of-the-art methods struggle to erase concepts cleanly without affecting other related concepts.
So there's a risk of creating new problems while trying to fix the old ones.
Exactly. And that's why this research is so important. It highlights the complexity of addressing bias in AI and emphasizes the need for rigorous testing and evaluation.
Absolutely. We need to make sure we're not just sweeping the problem under the rug. Okay, let's shift gears a bit and talk about this paper on multispectral scene understanding. What exactly does that mean, and why is it such a big deal?
Imagine an AI that can see beyond the visible spectrum, combining data from different sources like optical imagery, radar, and LiDAR. This paper proposes a framework called cross-modality diffusion that generates consistent images from novel viewpoints, even across these different modalities.
So it's like giving AI the ability to perceive the world in ways that we can't.
That's a great way to put it. This has huge potential for applications like self-driving cars, which need to be able to navigate in all sorts of conditions, including fog, rain, and darkness.
Right, it needs to be able to see what we can't see. And I imagine it could also be really valuable for things like environmental monitoring.
Absolutely. Imagine being able to analyze the health of a forest by combining satellite imagery with LiDAR data to create a 3D model that shows the height and density of the trees.
That's amazing. So it's all about giving AI a more complete and nuanced understanding of the world around us. Now, I'm seeing a paper titled Stereo, High-Frequency Details Matter, which seems to focus on a specific aspect of image processing, stereo images.
Stereo images are essential for depth perception, but they often suffer from quality issues, especially when they're compressed. This paper introduces a clever technique called stereo, which uses a diffusion model to recover those high-frequency details that are often lost during compression.
So it's like restoring a blurry old photograph to its original sharpness.
That's a good analogy. And these restored details are crucial for applications like 3D modeling, augmented reality, and even robotic surgery, where precise depth perception is essential.
Makes sense. Those are definitely areas where you don't want to be fuzzy on the details. Now, what about zero-shot monocular scene flow estimation in the wild? What exactly is scene flow, and what's so special about estimating it from a single camera?
Think of scene flow as depth estimation on steroids. Instead of just figuring out how far away things are, it predicts how they're moving in 3D space.
Whoa, so it's not just about where things are, but where they're going.
Exactly. And the fact that they can do this from a single camera is a major breakthrough. Traditionally, you would need multiple cameras or specialized sensors to capture this kind of information.
So this algorithm can basically predict the future movement of objects in a scene just by looking at a single image.
It's not predicting the future in a literal sense, but it's inferring the 3D motion of objects based on their current positions and velocities. And the zero-shot part means that this model can generalize well to new videos and scenes that it's never seen before.
Wow. This could revolutionize fields like robotics, autonomous navigation, and even sports analysis.
Absolutely. Imagine robots that can navigate complex environments more safely and efficiently. Or self-driving cars that can anticipate the movements of pedestrians and other vehicles with greater accuracy.
Okay, so we've covered some truly groundbreaking advances in image and video processing, from capturing subtle human movements to predicting 3D motion from a single camera. What's next on our agenda?
Well, you also sent over some research on how AI is being used to improve our understanding of complex systems, from the human brain to the dynamics of entire ecosystems.
That sounds fascinating. I'm ready to explore those complex systems. Welcome back. It's amazing to think about how much ground we've covered
Yeah, I
already.
know, right? And we've only just scratched the surface of all this incredible AI
It
research.
seems like AI is transforming every field imaginable these days, from self-driving cars to healthcare, and now even superpowered image processing.
It's not just about solving practical problems, though. AI is also pushing the boundaries of human creativity and communication, which is really exciting.
Okay, now you've got me intrigued. What have you seen in the research about that?
Well, you sent over some papers that delve into this area, and they're pretty thought-provoking.
Perfect. I'm ready to be provoked. What's caught your eye?
There's one here titled Frag Fray, a flexible modular framework for retrieval augmented generation based on knowledge graphs. It's a bit of a mouthful, but I think it has some interesting implications for AI and creativity.
Frag fray. Okay, so how does that connect to creativity?
Well, think about how human creativity often works. We connect seemingly disparate ideas or we draw inspiration from a wide range of sources.
Right, like sometimes the best ideas come from the most unexpected places.
Exactly. And Frag is all about helping large language models do something similar.
Okay, so you're saying it's giving them access to more information.
More than just information, it's giving them access to knowledge graphs, which are essentially vast networks of interconnected information. And it allows these models to actually utilize that knowledge in their creative process.
So it's not just about memorizing facts, but about understanding the relationships between them.
Exactly. And what's really cool about Frag is its flexibility and modularity,
Meaning,
meaning it can be adapted to different tasks and domains, so it's not just a one-trick pony.
I see, it's a versatile tool. So
Yeah.
like, what could you actually do with this?
Well, imagine an LLM that could write a screenplay, but also draw upon a vast knowledge of history, mythology, and science fiction to create a truly unique and compelling story.
That's a pretty wild idea. A screenplay that blends historical facts with, like, fantastical elements?
Precisely. It could even analyze existing screenplays and identify patterns or tropes to help writers break new ground.
Wow, okay, yeah, that would be pretty mind-blowing.
Huh.
But, as these LLMs become more powerful and creative, I also worry about them, making stuff up.
Ah, yes, the hallucination problem.
Right, exactly, like those moments when they generate text that sounds super plausible but is completely fabricated.
It's a legitimate concern, especially if we want to use LLMs for things like generating news articles or writing legal documents.
Yeah, the stakes get a lot higher when accuracy is
Yeah.
paramount.
Absolutely. So this other paper you sent, Attention-Guided Self-Reflection for Zero-Shot Hallucination Detection in Large Language Models, tackles this issue directly.
Okay, so what's the solution? Can we actually catch these hallucinations before they spread?
Well, it's not a foolproof solution, but it's a step in the right direction. This paper uses attention mechanisms to help the model identify when it's likely hallucinating.
Attention mechanisms.
Right. They're essentially ways for the model to focus on specific parts of its input or output to kind of pay attention to what it's doing.
So it's like the AI is learning to double-check its own work, to catch itself when it starts to go off the rails.
That's a good way to think about it. By analyzing its own attention patterns, the model can flag those outputs for further review.
Makes sense. So it's all about making the model more transparent, more accountable for its own creations. Okay, now this next paper has me really curious. Complex Func Bench, exploring multi-step and constrained function calling under long context scenarios. What are these function calls exactly?
Function calls are basically ways for LLMs to interact with external tools or APIs so they can do things beyond simply generating text.
Like what kind of things?
It could be anything from booking a flight to controlling a smart home device, even accessing real-time information from the web.
So it's like giving LLMs hands to interact with the real world.
Exactly. And Complex Func Bench is a benchmark designed to test how well LLMs can handle complex tasks that involve multiple steps, constraints, and long-range dependencies.
So it's like putting them through an obstacle course to see how well they can navigate the real world.
Precisely.
Okay, now, I see a paper on multi-stage training of bilingual Islamic LLM for neural passage retrieval, which highlights something I think is really important, the need for more multilingual AI systems.
Absolutely. Language diversity is crucial if we want to build AI that's inclusive and accessible to a global audience.
Right, it can't just be an English-speaking club.
Exactly. And this paper focuses on developing an LLM that can understand and retrieve information from Islamic texts in both Arabic and English.
Wow, so it could be a valuable resource for scholars, students, or anyone interested in learning more about Islam.
That's the idea. And the multi-stage training process ensures that the model can seamlessly switch between languages while maintaining accuracy and relevance.
That's impressive.
Yeah.
Sounds like a real challenge to train a model to be fluent in two languages and also deeply knowledgeable about a specific domain. Now, what about this paper? Hierarchical autoregressive transformers, combining byte and word-level processing for robust, adaptable language models.
hmm
What's the advantage of combining those different levels of processing?
So traditional language models often operate at the word level, right? They treat each word as a separate unit.
Right. But words are made up of letters, and letters can be combined in different ways.
Exactly. And this paper proposes a model that combines byte level and word level processing.
Bytes, like the ones and zeros that computers use.
Well, not exactly ones and zeros, but bytes are essentially chunks of digital information that can represent letters or other characters.
Okay, I'm following. So this model is looking at language at a finer level of detail.
Yes. By looking at both bytes and words, the model gets a more nuanced understanding of the underlying structure of language.
So it's like the model is learning to read at different levels of detail, from individual letters to whole words and phrases.
Exactly. And this hierarchical approach makes the model more robust to things like spelling errors or variations in language, and more adaptable to new languages and domains.
Got it. So it's more flexible and resilient. What about this paper titled Conversational Text Extraction with Large Language Models Using Retrieval Augmented Systems? It seems like it's tackling a very specific challenge, extracting information from conversations.
Extracting key information from conversations can be tough, even for us humans.
Yeah, think about trying to summarize a long, meandering meeting or customer service call.
Exactly. This paper presents a method that uses LLMs combined with information retrieval techniques to automatically pull out the essential information.
So imagine an LLM that could listen to a meeting and automatically generate a summary of the key points or action items.
That's the goal. It could be incredibly valuable for businesses, organizations, and even individuals who need to process a lot of conversational data.
This is a great example of how AI can help us be more efficient and productive in our daily lives. Now, what about this one? Enhancing generalization in chain of thought reasoning for smaller models. What's so important about making this type of reasoning more accessible to smaller models?
Chain of thought reasoning is a really powerful technique that lets LLMs solve complex problems by breaking them down into a series of steps, like we do.
Right. It's like showing their work so we can follow their logic.
Exactly. But it can be computationally expensive, which means it's not always feasible for smaller models or devices with limited resources.
I see. So this research is about democratizing access to this powerful AI technique.
Precisely. By making chain of thought reasoning more efficient, they're opening it up to a wider range of applications and users.
That's great. So it's not just about making the model smarter, but about making them more accessible and useful in the real world. Okay, last but not least, let's talk about this paper. Steering large language models with feature-guided activation additions. How do you steer an LLM without stifling its creativity?
That's a key challenge, finding that balance between control and freedom.
Right, we want them to be creative, but we also need to be sure they stay on track.
Exactly. And this paper introduces a technique that uses feature-guided activation additions to subtly influence the model's internal processes, steering it towards desired outputs while still allowing it to be creative.
So it's like giving the LLM a gentle nudge in the right direction without putting it in a straitjacket.
That's a great analogy. And this approach could be really valuable for applications where you need to ensure the model's output follows certain guidelines or constraints.
This has been an incredible journey. We've covered so much ground, from fundamental improvements in AI to some truly mind-bending applications. What are your final thoughts?
It's amazing to see the pace of progress in AI, and it's clear that this field is only going to become more influential in the years to come.
I totally agree. It's crucial that we develop these technologies responsibly and ethically as they become more powerful and integrated into our lives.
Absolutely.
Well, thanks for joining me on this incredible deep dive into the latest AI research. It's been a fascinating conversation, as always.
It's been my pleasure.
And to our listeners, thanks for tuning in. We hope you've enjoyed exploring the ever-evolving world of AI with us. Until next time, keep learning and stay curious.